Good day, dear students. Today's my lecture will be about the female reproductive system. It is system of organs which controlled by the hormonal and nervous mechanisms. They are its main function is the production of female gametes, the ova, by a process of ovogenesis, the reception of male gametes, the spermatozoa, provision of a suitable environment for fertilization of ova by spermatozoa, and for development of the fetus. A mechanism for expulsion of the developed fetus into the external environment, and also nutrition of the new baby. This scheme, look please on this scheme, it demonstrates you the organs, inner organs of the female reproductive system. Main gland, it is ovary, paired glands, which locates in the broad ligament, and special ligament carry ovary. Then next it is uterine tubes. You can see oviducts, or third name fallopian tubes, which take the developed ovum, mature ovum, and put it to the dilation of the uterine tube. You can see fimbria has these uterine tubes which looks like our fingers. These fingers catch the ovum and put it to the uterine tube. Here in this ample region of the uterine tube takes place the fertilization of the ovum. Then fertilized ovum or unfertilized ovum pass by this oviduct. If unfertilized ovum, it dies, but if fertilization happened, the first 7 days the embryos live in the uterine tubes, and on the 7th day of gestation reach the uterus. You see uterus, it is organ which responsible for the nutrition and of the first embryos, then fetus. Then uterus has the opening, cervix, and then it attached to the vagina. One more additional organ of the female reproductive system are mammary glands. Mammary glands are specialized for the nutrition of the newborn. Development of the female reproductive system is equal as male, same as male reproductive system. And as you remember the last my lecture, first 7 days of 7 weeks, of the gestation, in the embryos we can find so-called indifferent stage of the development, which is same for both sexes. And as you remember, indifferent stage has 2 ducts, Wolffian duct or mesonephric duct, and Mullerian duct, paramesonephric duct. And also genital ridges, which are derivatives of the mesial mesoderm, of the thickening on the anterior wall of the mesonephros, the second kidney, mesonephros. So this stage lasts 7 weeks, and then next events depends from the presence or absence of the SRY gene, which locates on the Y chromosome. So if embryos has no Y chromosome and has two X chromosomes, in this case SRY gene absent, and that's why absent the development of the Leydig cells, the testosterone productive cells, and don't develops the Sertoli cells. Sertoli cells which produce anti-Mullerian hormone or anti-Mullerian inhibiting factor. That's why in the situation when testosterone absent, the Wolffian duct don't permit the development, and if absent anti-Mullerian hormone, Wolffian duct obliterates and Mullerian ducts get further development. And these Mullerian ducts are precursors of the female genital tract. So genital ridges which are invaded by the gonoblasts and cuboidal mesenchymal cells of the mesoderm and mesenchyme develops into the follicular cells, and regular architecture of the genital cords which can develops in the way of the seminiferous tubules, but now without testosterone, no seminiferous tubules, the organization of the genital ridges dissolve and reorganized, appear primordial follicles. And these primordial follicles, it is gonoblasts which are covered by one layer of the cuboidal mesenchymal cells. And the genital ridges go in the way of the development of the ovary. So the development and differentiation of the organs of this female reproductive system are not completed until the hypophyseal gonadotropic hormones begin to appear at about 10 years of age. And these changes culminate with the initiation of menstrual cycle at menarche, which occurs at about 13 years of age. It depends of the personal features of girl, maybe earlier, maybe later, but approximately about 13 years of age. Therefore, throughout the reproductive period, the ovaries, genital ducts, and mammary glands undergo cyclic changes in structure and function associated with the menstrual cycle, which averages about 28 to 30 days in length. So let's talk about the main organ of the female reproductive system, paired organ, which is called as ovary. So ovary has dual function, like testis. First of all, it is exocrine function, production of the female sex cells, and endocrine secretion, production of female sex hormone. Now you see the section, hematoxylinase section of the ovary. On this section you can see that organ is covered by the comparatively thick tunica albuginea. It is dense, irregular connective tissue which is covered by simple columnar epithelium. It is modification of mesothelium, and you can see that capsule is comparatively thick. Just under the capsule, on the section, we can see the cortex or cortical region. All these components locates in the cortex. And the central aspects of the organ, it is the medulla. Inner portion, it is medulla. Now you can see medulla. And if you will look again on this picture, you will see that there is no distinct line of demarcation between the two zones. The medulla and cortex we can recognize only according to the components which locates or structures which locates in these parts of the organ. We can see that medulla consists of the loose connective tissue, fibroelastic tissue, which contains numerous blood vessels. You can see numerous blood vessels, lymphatic vessels, and nerves. And in the stroma, scattered strands of smooth muscle fibers. Please look on this scheme. Now it is scheme of the section of the ovary, and you can see that cortex, this is cortex, which locates under the capsule, tunical buginea, then cortex, and in the center is medulla. Stroma is equal for medulla and for the cortex. It is reticular stroma. Here we can find a lot of reticular fibers and spindle-shaped cells arranged in irregular whorls. The follicles may be seen only in cortex, and in the ovary of woman, follicles may be on different steps of its development. This process is called as follicular genesis. Under the tunical buginea, on the periphery of the cortex, you can see many small follicles, so-called primordial follicles. Then they differentiates into the primary follicles. So these follicles appear only in the embryonic period of lifespan, and in the moment of the childbirth of the girl, the number of these primordial follicles is limited to, according to different data of statistics, they may be from 200,000 to 400,000 of the follicles. That's why in the adult woman, adult girl, in the cortex under the capsule we can see primordial follicles. But also we can see the growing follicles, like the primary follicles, secondary follicles, tertiary follicle, or preavulatory follicle. You see growing follicles. Then their end products may be like corpus luteum, corpus albicans, and atretic follicles. Now it is atretic follicles. But this is scheme. In native condition, in real microslides of the ovary, we can't see together growing follicles and corpus luteum. Later I'll explain you why. In the same time, in the same day, we can't see growing follicles, especially preovulatory follicle and corpus luteum. It is impossible. But this is scheme for your education. After menopause, after 45-55 years of lifespan, follicles disappear in the ovary of the aged woman, and cortex eventually becomes a narrow zone of fibrous connective tissue. So primary follicles also can disappear, and of course the growing follicles. This period of lifespan of the woman is called as menopause. So what follicles may be in the cortex? Now, first of all, I told you primordial follicles. Look please on this hematoxylin section of the ovary. You can see the tulicate buginea and epithelium, so-called germinative epithelium or mesothelium also, and you can see that these cells are cuboidal, one layer of these cells. And just under the capsule locates these small follicles. And inside, if it is postnatal period, gonoblasts differentiates into the primary follicle. Gonoblasts inside grow and appear step by step primary follicles, primary oocyte inside. And around this primary oocyte we can see the one layer of the columnar, so-called flattened epithelial cells, follicular cells. And if it is epithelial cell, have to be basal lamina. The basal lamina covers the outer surface of the follicle. Now look around, you can see a lot of primordial follicles which are covered by one layer of follicular cells. Next stage of the follicular genesis, it is growing follicles. Growing follicles, it is progressive development of follicles that occurs after puberty, and it means the changing in the cytologic characteristic of sex cell, gonoblast, and now primary oocyte, and the wall of the follicle. So next step, it is growing follicles. Now you can see that follicle become larger, oocyte also become larger, and around is one or two layers of the follicular cells, also which lies on the basal lamina. These changes also happened in the oocyte. Oocytes start to produce zona pellucida around it. The cytolem of the oocyte is vitelline membrane, as you remember. But second tunic, it is zona pellucida. Zona pellucida contains three different glycoproteins, ZP1, ZP2, and ZP3, which are secreted by the oocyte. Microvilli of oocyte and filopodia of the follicular cell invades the zona pellucida, come in contact with each other, and form gap junctions through which they communicate throughout follicular development. Look here, it is the scan electron microgram of the outer surface of such follicle, and we can see the zona pellucida and follicular cells on the outer surface. These small balls are follicular cells. Next step of the formation of the growth of the follicles, when the follicle increase the number of the follicular cells. Now you can see the primary oocyte, which is covered by the zona pellucida, and the follicular cells now forms 3-4 layers. You see 1, 2, 3, 4 layers. It is the section of the growing follicle. Now it is the secondary follicle, and we can see that connective tissue, fibroelastic connective tissue of the stroma in the cortex forms the so-called the covering of the follicle, tecas, and connective tissue of the stroma, ovarian stroma, forms the theca externa, which consists of collagen fibers, pink collagen fibers, outer tunica externa, and inner tunica interna. Here locates the cells which looks like fibroblasts. Tunica externa and tunica interna is vascularized. Blood capillaries come from the stroma of the ovary. But now you also can see the inner covering of the follicle, so-called the stratum granulosum, which composed of granulosa cells. Granulosa cells, it is modified follicular cells, which you see on the previous microslide. When follicle grow, the follicular cells undergo mitosis, proliferation, and modify into the granulosa cells. And these granulosa cells, now you see, forms several layers and so-called granulosa layer. Granulosa layer you can see. And also basal lamina, because epithelial cells need basal lamina. That's why granulosa, theca interna, and theca externa. Very interesting that these follicular cells are controlled by the follicular-stimulating hormone. They continued proliferation of the granulosa cell of the secondary follicle. And this FSH hormone, as you remember, released by basophilic cells of the anterior pituitary. It is gonadotroph cells which produce this gonadotropic hormone, follicular-stimulating hormone. It means that the granulosa cells, sometimes we call it also as follicular cells, has receptors for this FSH hormone. Next, changes which happen during the growth of the follicles that appear the antral follicle, so-called secondary antral follicle. Follicular cells which are stimulated by the follicular-stimulating hormone are hormone productive itself also. They produce when they proliferate, when they increase in number, they produce hormones, estrogens. It is family of hormone which main of this family is hormone estradiol, and also granulosa cells produce liquid, serose liquid, and this liquid concentrates in the center of the follicle. You can see appear the spaces, free spaces with the liquid. This liquid push the oocyte together with the zona pellucida and some portion of follicular granulosa cells to one to the periphery of the follicle, to the wall of the follicle. And this region, you can see that free space which is filled by the fluid with estrogens, and you can see the granulosa cells around oocyte which continue into the granulosa cell of the wall of the follicle, and this region is called as cumulus or forus. Cumulus or forus. Follicular cells produce not only family of estrogen hormones, they also produce inhibin, hormone inhibin, foliostatin, and activin. And these hormones regulate the release of follicular stimulating hormone and the second hormone, gonadotroph hormone, of the which produced by the gonadotroph cells, LH hormone. Remember that it is luteinizing hormone. Luteinizing hormone. On this stage, very often the follicle can undergo atresia. Atresia. What does it mean, atresia? No, it is generally it is death of the follicle, and most of the growing follicles undergo atresia, and more often on the stage of the antral follicle. In this case, oocyte and follicular cells are killed by the hormone inhibin, but some follicular cells stay inside these atretic follicles and serves it as interstitial gland, so-called interstitial gland, and this interstitial gland can live in the cortex of the ovary for a long time, produce androgen hormones, and live until menopause, so many years. Some of them dissolve, but some of them stay as atretic follicles in the cortex of the ovary. But few antral follicles continue to develop into mature follicles. So now this upper picture shows you the section, histologic section stained by hematoxyliniazine of the tertiary follicle. It is the next stage of the folliculogenesis. In human ovary, these follicles are requires on 10 to 14 days of they need 10 to 14 days to reach maturity. And mature follicle, tertiary follicle, also is called as Graafian follicle. Synonyms: Graafian follicle, or next synonym, pre-ovulatory follicle. And in human ovary, the size of this follicle may be up to 10 millimeters in diameter, or sometimes even more. It bulges on the free surface of the ovary, and this region of the ovary called stigma. In this region, tunica albuginea of the ovary and the theca folliculi, theca externa of the folliculi, become attenuated. The large antrum, you can see, is filled, distended by the water, and bounded by the stratum granulosum. The ovum has attained its full size, and ovum inside has 3 tunics. Innermost, invisible here, vitelline membrane, then thick zona pellucida, and so-called corona radiata. It is several layers of the follicular granulosa cells who are hormone productive, produce hormones, estrogens. So, as you see, the wall of the follicle is also thick and has thecas, theca externa, theca interna, and a layer of the granulosa cells innermost, which rest on the basal lamina. Now you can see in details, larger magnification demonstrate you the wall of the Graafian follicle. You can see it is antrum, so you can see the basal lamina, several layers of granulosa cells, then tunica interna, special cells which are derivatives of the stromal cells of the cortex, and then theca externa, thick bundles of the collagen fibers. And you can see that here present in thecas present blood capillaries. This scheme shows you the folliculogenesis changes. Everything starts from the primordial small follicule with the small oocyte inside, outside of the first order, then unilaminar primary follicule, which is larger than this primordial of, sometimes we call it also primary follicle. You have to understand that primary follicle usually have only one layer of the follicular cells which rest on the basal lamina. Here start to develop the zona pellucida, then multi-layered primary follicule. Usually we call them as secondary follicle. If appear more than one layer of the follicular cells, it means that it's on the way of the formation of secondary follicle. When the secondary follicle start to appear the thecas, theca externa, theca interna, and granulosa, layer of granulosa cells innermost layer. Then antral follicle, which I showed you, follicular cells produce, or granulosa cells produce a family of hormones. The main is estrogens, also inhibin hormone, which kill the neighbor follicles, also some glycosaminoglycans, and you can see that this ovum with 3 tunics pushed to the periphery and forms the cumulus ophorus. Here it is cumulus ophorus. And tertiary follicle or Graafian follicle or pre-ovulatory follicle, when you can see that this liquid distends the wall of the follicle, we can clearly see 3 layers in the wall: tunica granulosa, with the granulosa cells, theca interna and theca externa. Ovum has zona pellucida and corona radiata. In the region where corona radiata is attached to the tunica to the granulosa layer, forms the cumulus ophorus, and in this region you can see that these 2 structures fuse with one another, and the wall of the follicle become thinner, thinner, and thinner. It is here forms the stigma. Later will be eruption of the follicle in this region. If follicle reaches maturity, there is increased secretion of liquor, more watery than that formed previously, which cause the expansion in diameter of the follicle. This is termed preovulatory swelling. The follicle covered with thinned cortex ruptures at the stigma. I showed you the place of the future stigma, and follicular fluid go out from the follicle into the peritoneal cavity, and ovum also go to the peritoneal cavity, and this process constitutes ovulation. That's why, what is it, ovulation? It is rupture of the wall of the follicle and tunical bugynia of the ovary. And in this case appear the opening and fluid, liquor inside the follicle together with the ovum, which has 3 tunics, go to the abdominal cavity. And here in peritoneal cavity, this free ovum usually is directed into the infundibulum of the fallopian tubes. I told you that opened distal part of the oviduct has dilation. We call it as ampulla, and this ampulla ends by the fimbrias, which looks like our fingers. And these fingers catch this free ovum and direct it to the ampulla region. And here, during the future 24 hours, ovum have to be fertilized by the sperm cells, which can reach this ampulla region of the fallopian tubes. But if spermatozoons will not come, after 24 hours, the ovum will die. Now, very interesting that the recent researchers said that ovum can live in the uterine tubes even 3-5 days. But classic books give you 24 hours. In the human female, ovulation normally occurs at interval averaging 28 days. It means every 28 days in ovary takes place ovulation, appear mature ovum which can be fertilized. Very interesting that in woman, in mature adult girl, every 28 days appear only one ovum, and usually a woman can born only one baby, but sometimes maybe ovulation in 2 follicles. No, according to the statistic in the world, the maximum of babies who don't look like one another, maybe of different sexes, it means that for each baby was its own ovum. That's why even up to 6 ovums can get, follicles can get the stage of the graphen follicle and ovulate, but it is very rare. Sometimes some drugs may stimulate ovarian activity and cause the simultaneous maturation of several follicles, thus increase the possibility of multiple births. Some hormones which is used for the treatment of the woman, some other manipulations, but the multiple births, it is rare cases, and statistics says us how many women has can have, for example, 10,000 women normally can have only one baby, and even one from these 10,000 women can have double or two babies, that two follicles get the stage of the ovulation. Now, of course, we don't talk about the in vitro fertilization because it is not normal situation. It is special procedure, and multiple births in this multiple pregnancy here appear because of special manipulation. We talk about the normal condition, native condition. Last my lecture, I told you about the spermatogenesis. Spermatogenesis is the development of the spermatozoans, male gametes. Female gametes, ovums, also develops as a result of process of oogenesis. And if spermatogenesis has 4 phases, remember, multiplication, phase of growth, phase of maturation, and phase of formation. Here in oogenesis we can find only 3 phases: phase of multiplication, phase of growth, and phase of maturation. Only 3. The phase of formation absent. And there are some difference between these phases in spermatogenesis and oogenesis. So the first stage of multiplication in oogenesis can happen only in female fetus. Oogonia, or primitive ova, has the same origin as the spermatogonia. They develop from the gonoblasts, which come to the genital regions from the yolk sac. But the mitotic division of female sex cells can take place only in the fetus. And when the newborn girl appears, in her ovary is the limited number of oogonia. And this oogonia may be over, I told you, 200,000 to 400,000 of primordial follicles. Oogonia never leave itself. It usually part of the primordial follicle. Around the oogonia, cuboidal cells of the mesenchymal origin from the mesial mesoderm forms the one layer which rests on the basal lamina. So in the cortex of the ovary of the newborn girl, we can see the primordial small follicles with the oogonia inside. Then after the childbirth, start the phase of the growth. And this phase of the growth in the ovary of the girl is subdivided into two stages. The first stage of slow growth. This slow growth lasts till puberty. It covers over 13 years. During this slow growth, the primordial follicles slightly grow and change into the primary follicles. Ovagonia also grow, and we call it now as primary oocyte. Primary oocyte is covered by one layer of the cuboidal follicular cells which rest on the basal lamina. Over 13 years of the postnatal life activates the hypophysis and start to produce the gonadotroph hormone, follicular stimulating hormone. And under the influence of this hormone start the sexual differentiation of the girl and appear the sex cycles which lasts 28 days. That's why when start these cycles, some primary follicles, not all together, 200,000. Why over 10 follicles start the phase of the fast growth? I can't explain you. No, now we don't fully understand why only several follicles start the phase of the fast growth. Others stay relaxed and don't participate in this process. So, some follicles start the phase of the fast growth, and this fast growth begins cyclically each 28 days. And these follicles grow over 12 days, first part of the sex cycle. And when this process is called as follicular genesis. I explained you the follicular genesis, that primary follicle grow, enlarge, appear secondary follicle, then appear the antral follicle, and at the end of this period, up to the 12th day of sex cycle, appear the tertiary or Graafian or pre-ovulatory follicle. This follicle is very large, I told you, and is ready for ovulation. Then start the next phase of ovogenesis, phase of the maturation. So the first maturation division result in the formation of one daughter cell, which we call as secondary oocyte, and first polar body. As you remember the spermatogenesis, maturation means meiosis. Meiosis, it is genetic type of division, and consists of two steps of division, the first division of maturation and the second one. So in ovogenesis it's the same. The first division of maturation lead to the formation of secondary oocyte and first polar bodies. If in spermatogenesis we get the two equal secondary spermatocytes, now another picture. now appear the large cell secondary oocyte, which receives particularly all the cytoplasm of the mother cell. The other cell is very small, first polar bodies. It only has nucleus, thin ring of cytoplasm, and very soon degenerates. At about this time, ovulation occurs. After the first division of maturation occurs the ovulation, and the secondary oocyte is released from the follicle and then pass to the uterine tube. And penetration of the spermatozoon head into the oocyte stimulated to complete the meiotic division. That's why the second division of maturation usually takes place only during fertilization. If no fertilization, no the second division. After the second division of maturation, appear the mature ovum, now with the haploid number of chromosomes, and appear the second polar body, which take the also the haploid number of chromosomes. And this polar bodies also is very small and very soon degenerate. That's why after the meiotic division appear the mature ovum, large cell which take all the cytoplasm, organelles, your granules from the previous cell, secondary spermatooocyte. And phase of formation, I told you, absent. Let's now again return back to the ovary. What happened after the ovulation? After ovulation, there is sometimes a little bleeding into the cavity of the follicle. So stay follicle, over primary oocyte together with 2-3 membranes go away, and from these openings, from erupted capillaries, blood go to the cavity, small bleeding. The wall of the follicle collapses and is thrown into folds. You see? The follicular wall becomes transformation into a temporary glandular structure, the corpus luteum, so-called corpus luteum. This is here. You can see these folds. You can see the bleeding, which later transformed into the connective tissue, white scar. And you can see that layers of the theca and granulosa cells start to transformate into another cells. These cells enlarge, proliferate, and begin secrete steroidal hormones. So the granulosa lutein cells, cells which differentiates from the innermost layer granulosa, here pale staining cells, they are most numerous. They are large, pale staining, and we call them as lutein cells, theca lutein cells. You see this what here? You see that cells are polygonal and shaped, has one nucleus in the center, and a lot of lipid inclusions, because it's produces a lipid-soluble hormone, steroid, progesterone. But some cells from the thecas, you see, dark staining cells, also proliferate, but not so fast like the cells of the theca granulosa from the layer of granulosa cells. And these theca lutein cells produce again estrogens, but in very low concentration. That's why in the ovary, look here, pay attention to this picture. It is light microscopic picture of hematoxyliniazine stained picture of the granulosa lutein cells. You can see that it is pale staining cells. In native condition, they have yellowish color because of a lot of lipofuscin granules. But after histologic technique, they are oxyphilic pale staining, one nucleus in the center, oval-shaped or spheric cells, which actively produce the second female sex hormone, progesterone. Now you understand that if follicle erupted and ovum go away, the production of estrogen stops. Follicular stimulating hormones stop its activity, and production of estrogen stops. Only very few estrogens produced in corpus luteum by the theca lutein cells, here dark cells. Most of the cells of the corpus luteum are granulosa lutein cells, which you see here. And these cells produce progesterone. That's why in the blood of the woman, after the 13th day of sex cycle, after the ovulation, we can find the hormone progesterone. But hormones estrogens decrease in concentration, and we can find very low minimum level of estrogens. This is cyclic changes, hormonal cycle changes, cyclic changes. How long lives the corpus luteum? We distinguish two types of corpus luteum. Corpus luteum of menstruation. It means that corpus luteum lives up to the end of the sex cycle, up to the 28th or 27th day of the sex cycle, from 14th day to 27 days, and produce progesterone, of course. But then, if pregnancy absent, step by step, the lutein cells undergo degradation. The concentration of progesterone slightly decrease in the blood of the woman, and sex cycle go to the end. And the 28th day of sex cycle, in the blood of the woman, we can't find high concentration of any ovarian hormones. Very low level of estrogens and very low level of progesterone. So in this case, step by step, corpus luteum degenerates and replaced by the corpus albicans. It is really white scar. You see white scar. Now you see the degraded cells, lutein cells, and in the center increase in size the white scar. And this white scar, corpus albicans, may be over 1 or 2 years, and then dissolve in the stroma of the cortex, of the ovarian cortex. But if pregnancy happened and ovum is fertilized. The corpus luteum increases in size and becomes the corpus luteum of pregnancy. Progesterone, it is critically important for pregnancy. This hormone we call as the hormone which saves the pregnancy, and progesterone is necessary for the implantation of the embryos, for the placentation, for the further growth of the uterus, growth of the fetus, and also later placenta help to maintain the production of hormones in the corpus luteum of pregnancy. Chorionic gonadotropin helps the corpus luteum to produce progesterone. And usually this corpus luteum of pregnancy enlarge, become very large, and lives up to the end of the pregnancy. When pregnancy comes to the 280 days, corpus luteum of the pregnancy has the same destiny as the corpus luteum of menstruation. It degrade, cells degrade and replaced by the connective tissue scar. Now, of course, corpus albicans is larger and stay in the cortex of the ovary several years, more than 1-2 years. Again, about follicles. I told you that at the stage of the antral follicle, most of follicles undergo atresia. You have to understand that the phase of the fast growth started there up to 50 follicles, sometimes 10, sometimes up to 50 follicles. They begin to mature in each menstrual cycle, and as many as 5 may reach the stage of Graafian follicle. What happened with other? Other follicles undergo atresia, and the stage of the Graafian follicle, tertiary follicle, can reach only one dominant follicle. Why this follicle can do this? This follicle more actively produce the hormone inhibin by the follicles in the follicular cells, and this hormone inhibin suppresses releasing of the follicular stimulating hormone by the anterior pituitary. This dominant follicle close the receptors for follicular stimulating hormone, but other follicles can't do this, and they die without stimulation by the follicular stimulating hormone, which level decrease. These follicles undergo atresia. The lack of the follicular stimulating hormone causes the remaining Graafian follicles that are still FSH dependent to atrophy, leaving only the dominant Graafian follicle. That's why only the largest and the strongest follicle can get the stage of the mature follicle, Graafian follicle, and even in these near 5 Graafian follicles, only the larger, the strongest ovulate. Others also undergo atrophy. So atrophy means that the atrophic processes takes place in the ovum and follicular cells. The zona pellucida swells and may persist for some time after the disappearance of the ovum and follicular cells. Macrophages invade the atretic follicle and remove degenerating material, including fragments of the zona pellucida. So, after final resorption of the follicular cells, the theca cells degenerate and are replaced by connective tissue. The resulting mass of scar tissue are similar in appearance to corpora albicans, but now we call it as corpora atretica. It is also the same connective tissue white scar. But I told you in the beginning that some atretic follicles stay in the cortex of the ovary, and even their cells can modify and produce androgens. It means testosterone, and some of them can live even to menopause, even to 55 years, 45, 55 years of the woman. You can see the picture of the atretic follicles. Atresia of the follicles, you can see this follicle. You can see that wall of the follicle damaged. You see granulosa cells, here it is, some of them died. You see that disappeared the cells of the cumulus auforus, corona radiata around the all side damaged, zona pellucida also thin, and you can see the theca delaminate, and step by step appear cavities you see in the theca, and step by step this follicle can replaced by the connective tissue scar. But some can live, and the granulosa cells can stay, some of them, and produce even testosterone androgens. Now, ovarian cycle. I told you that female reproductive system is closely regulated by the nerve system and endocrine system. Today we know that hypothalamus produce lutropins. It is releasing factors, liberins, which stimulate the trophic cells of the pars distalis of pituitary. So gonadotroph stimulating hormone stimulate the gonadotroph cell, basophilic cell, of the anterior pituitary, which produce follicular stimulating hormone. You can see follicular stimulating hormone, which stimulate the folliculogenesis, and follicular cells, granulosa cells, produce estrogens, which also, according to the feedback mechanism, has influence on the hypothalamus. You see, on the way of stimulating hormones of hypothalamus. Follicular stimulating hormone acts during the lutein, estrogen phase of ovarian cycle. Then, at the second part, lutein phase of the sex cycle, menstrual cycle, function the gonadotroph cell produce the LH hormone, luteinizing hormone. This luteinizing hormone has influence on the follicle and stimulate the ovulation, eruption of the follicle, and the ovum go away to the abdominal cavity. And also then luteinizing hormone stimulate the transformation of the ovulated follicle into the corpus luteum. Corpus luteum start to produce progesterone, which later also has influence on the hypothalamic hormones, releasing hormones for gonadotroph cell. So follicular phase lasts 14 days up to ovulation, and luteal phase from 14th to the 28th day. Very interesting, but the recent research says that ovulation is stimulated not only by and not mostly by the luteinizing hormone. Very important is hormone prolactin. Especially prolactin stimulate the eruption of the follicle. Prolactin, as you remember, it is secretory product of the mammotroph cells of the adenohypophysis. It is oxyphilic cells. And also this hormone stimulated the lactation, production of the milk in the mammary gland after the childbirth. So now I explained you the ovarian cycle. Also pay attention, I told you, but now I want to underline that after fertilization of the ovum, takes place the placentation, formation of the placenta, and chorionic gonadotropin of the placenta has influence on the corpus luteum and maintains the stimulate the production of progesterone. Corpus luteum, I told you, can produce some estrogens also, but in very low concentration. Now about fallopian tubes. Fallopian tubes are paired structures. It is really tubes, 12 to 15 centimeters long in woman and about 1 centimeter in diameter. The tube receives the ovum released at ovulation, provides the appropriate environment for its fertilization and initial development, and transport it to the uterine cavity. So one end of the tube opens into the uterus, the second opposite end is opened and opened into the abdominal cavity. The wall of the tube has 4 tunics. It is really tube. It has tunica mucosa, tunica submucosa may be absent or very, very low developed. Then tunica muscularis and serosa. Tunica mucosa, innermost tunic, is covered by the simple columnar ciliated epithelium. And tunica mucosa forms the long folds, longitudinal folds or plica. In the ampulla region where takes place fertilization, the folds branch in a complex manner to divide the lumen into a labyrinth of spaces, and in one of these spaces takes place fertilization. A simple columnar ciliated epithelium has 2 principal types of cells. First, it is simple columnar cells, tall columnar cells with the cilia's. Ciliated cells usually occur in small groups, and between them are groups of cells without cilia's, non-ciliated cells. These cells are more narrow and secrete fluid. Lumen of the uterine tube has liquid, but cilia's has cilia. It is organelle of movement, remember. You see, it is the scanning electron microgram. Cilia's constantly beat towards the uterus and are thought to play a major role in transportation of the ovum through the ampulla to the ampulla isthmic junction, the normal site of fertilization. No, it means that to the cavity of the uterus. So these cilia beat in the direction of the ovum and push the fertilized so the cilia beat in the direction of the uterus and push the fertilized ovum embryos to the uterus. Also, same function has the liquid, which is a secretory product of secretory cells, and the direction of the flow of the liquid is also to the uterus. And same mechanism this mechanism has the third component. The constant contractions of the tunica muscularis of uterine tube is also, the waves of the contraction is also direct to the uterus. So these three mechanisms help the fertilized ovum to reach the uterus. If this mechanism will damaged, the ovum can implantate here in the uterine tube. And you can see that the wall of this tube is very thin, and embryos can live in the uterine tube no more than 8 weeks. The chorionic villi penetrate deeper, deeper, and deeper, erupt the wall of the tube, appear the hole, and embryos go to the abdominal cavity and start the inner bleeding in the peritoneal cavity of the woman from the erupted blood capillaries of the oviduct wall. So the epithelium of the uterine tubes undergo also the cyclic changes according to the ovarian cycle, and in the follicular phase the height of the epithelium is greater, and in the luteal phase is lower, and the activity of the cilia also is greater in the follicular phase. You can see, this is the light microscopic picture. You can see folds, deep branched folds, which forms the spaces between folds where can be the ovum, and here can happen fertilization. So lamina propria of the tunica mucosa, you can see it is loose connective tissue, and thin basal lamina separated the simple columnar ciliated epithelium from the lamina propria. Tunica submucosa usually absent. Tunica muscularis consists of inner circular and thin outer layer. Contraction of the muscular cord occurs in peristaltic waves, aid in the movement of the ovum down the tube to the uterine cavity. And the outer surface of the uterine tube is covered by the peritoneum. That's why appear the tunica serosa, loose connective tissue which is covered by the mesothelium, by the peritoneum. Now some words about uterus. Uterus, it is a thick-walled segment of the tubular female reproductive system. I want to say you that uterine tubes, uterus, develops from the paramesonephric duct, from the Mullerian duct. Mullerian duct in the upper third give rise to tubes, stay separate, each duct, but lower in the middle and the lower third, two ducts fuse with one another and appear uterus. In human uterus, it has the flask shape. Human uterus is flask shaped, and because of attachment of two ducts to one another. And the wall of uterus consists of 3 layers. They have its own name, I am sure that you know. The innermost endometrium, the middle myometrium, and the outer perimetrium. Perimetrium, it is typically tunica serosa, tunica adventitia, which is covered by the simple squamous epithelium. Myometrium, it is massive coat of smooth muscles, comparatively very thick tunic myometrium. Here are smooth muscle cells which can be subdivided into 3 layers. The inner muscular layer, stratum subvasculare, middle layer, stratum vasculare, and the outer, it is stratum supravasculare. These layers, especially the stratum vasculare, is very highly vascularized. Numerous blood vessels travel here. The endometrium consists of simple columnar ciliated epithelium which rests on the basal lamina and lamina propria, but here we call it as stroma of the endometrium. The invagination of epithelium of the endometrium into the lamina propria we call as uterine glands. Uterine glands. These glands, its branching and secretion depends from the phase of the sex cycle. All these endometrium components is under the influence of the ovarian hormones, and they have different construction in the follicular stage or postmenstrual stage, in the luteal phase or premenstrual phase, and menstrual phase. 3 phases has cell cycle in the uterus. Now about vascularization of the uterus. It is very rich, uterus is very rich in vascularization. So arcuata arteries come to the myometrium and run circumferentially within the myometrium. They send 2 branches. One of them we call as radial arteries, and these arteries go to the endometrium. In the region of the myometrial endometrial junction, these arteries give of basal or straight arteries, called as basal or straight arteries, and they supply the basal part of endometrium. Endometrium is subdivided into 2 parts, the deepest basal part and the upper part functional layer. Functional layer undergo the cyclic changes according to their variant hormones, but basal don't have any changes. That's why straight arteries, which supply the basal part of endometrium, stay straight during all the periods of the sex cycle. So the radial arteries continue upward into the endometrium and become highly coiled spiral arteries. So from the straight arteries start the highly coiled spiral arteries, and the latter ramify into arterioles that supply a rich capillary bed in the superficial portion of the endometrium. So I told you cyclic changes in the endometrium: menstrual phase, first phase of the sex cycle, then postmenstrual proliferative phase, and premenstrual or progestational or luteal stage. Proliferative, progestational, luteal stage. So menstrual phase means that the level of estrogens and progesterone is very low. I explained you why. During the proliferative phase, in ovaries start the folliculogenesis, and in the blood of the woman present estrogens. Then the decrease takes place at the ovulation, and after the ovulation, corpus luteum produces progesterone. And in the blood of the woman, we can find the high level of progesterone and low minimum of estrogens. At the end of the sex cycle, when the corpus luteum starts to degrade in the blood of the woman, we can find minimum level of both hormones, ovarian hormones, estrogens and progesterone. And these low levels stimulate the menstrual phase, menstrual stage of the changes in the endometrium. These cyclic changes, I told you, only takes place only in the functional layer. And during the menstrual phase, this accommodates only the functional layer of endometrium. You can see basal stay without damaging. Straight arteries never discommates. Discommates only the functional layer with the spiral arteries, epithelium, and glands up to the bottoms of the glands. Stay bottoms of the glands. After menstruation, all these components go away. Discommates and go away from the uterus together with the blood. Then started the proliferative phase, follicular phase, when blood capillaries and spiral arteries closed, bleeding proliferates cells, restore these arteries and capillaries, and bleeding stops. Endometrium again is covered by the simple columnar ciliated epithelium, which invaginates and forms the glands. But glands now are straight, without branching, and don't secrete. Then after ovulation, under the influence of progesterone, during the luteal phase of ovarian cycle, the spiral arteries become very branches. You can see that glands also branch. You see appear the secretory portions, and the glands start to produce secret, mucus secret. Also in the basal, in this function layer, appear special cells. Cells here absent on this scheme. Decidual cells. Decidual cells. These cells present only during the premenstrual phase of the sex cycle. Then during the menstruation, when takes place the disformation of the functional layer, these cells together with other components of the functional layer go away. And now some words about mammary glands. Mammary glands, it is modified sweat glands of the skin. They present in both sexes, but well developed only in female organism. In both sexes, they are slightly developed during the childhood. At puberty, in female, the glands enlarge rapidly, principally as a result of development of adipose and other connective tissue. In male, they develop very slow and don't get the high, don't become large. So the gland, mammary gland, its histological features depends from the function. Before the pregnancy, mammary gland consists only from the excretory ducts, main excretory ducts, which now we call as lactiferous ducts and lactiferous sinus. Lactiferous sinus opens independently on the surface of the richly innervated nipple papilla. And we can see only 15 to 25 lobes in such mammary gland. And between these lactiferous ducts and sinus, we can find a lot of adipose tissue, fat storing cells, and bands of dense connective tissue. Now you see the upper picture. It is inactive mammary gland before the pregnancy. You can see only the lactiferous ducts and sinuses, which opens in the nipple, and a lot of, you see, white adipose cells and connective tissue. But during the pregnancy, the mammary gland get the further development. Appear its lactiferous ducts branched, and appear the secretory portions. These portions, this gland is alveolar gland. Secretory portions looks like small balls, and around these balls is also white adipose tissue and connective tissue. You see, before the pregnancy appear the alveolar secretory portions during the pregnancy, and after the pregnancy, this gland nutrite the newborn. This is the top of the development of the mammary gland. You see secretory portions enlarge. Here appear 3 types of cells. First, it is lactocytes, which secrete by the epicrine type, secrete the lipids. The smaller cells secrete protein components of the milk and fluid, secretion by the merocrine type, and myepithelial cells. Myepithelial cells, of course, present everywhere in the previous stages, because this gland has ectoderm origin, but now we can clearly see in lactating gland, we can clearly see these myepithelial cells as the outer layer around the alveoli, secretory portions. So this picture show you the cells and its type of secretion in the alveoli of the mammary gland during lactation. You can see the tall columnar cells with the lipid droplets, which separates, you see, as apocrine type of secretion. Apical part of the cell become the component of the secret. The second type of lactocytes, it is cells with here absent with protein secretion and liquid secretion, merocrine type of secretion without damaging of the cell. You can see the myepithelial cells, elongated oval-shaped cells with the long processes which can contract and push the secret outside from the lactocytes. Capillaries, of course, present. It is light microscopic picture stained by hematoxylinazine. You can see the tall cells which have the apocrine type secretion and small cells, lactocytes, which has the merocrine type of secretion. Myepithelial cells also here. And you see that spheric ovoidal secretory portions and thick septors, connective tissue septors between the secretory portions of the mammary glands. So, doctors, I will tell you everything about the organs of the female reproductive system. Thanks for your attention. The time is finished and you may be free. Goodbye.